Welcome to the session. Today's topic of the session is the three-phase circuits and its problem solving. So, myself Ajit Suryawanshi, working as an assistant professor in the program Electronics and Telecommunication Engineering in Walchand Institute of Technology, Solapur. So what will be the outcome of this today's session? At the end of the session, student will able to analyze the three-phase star and delta circuits. So what should the knowledge you should possess before proceeding to the session is that a student should have a basic knowledge of an AC circuits, basic fundamentals of the AC circuit, single phase AC circuits. So that should the knowledge you should have before proceeding into the three phase AC circuits. So what is meant by the three-phase AC circuits? So name itself suggests that three-phase means it has a three coils or three different phases of an alternating current or alternating voltage. So to generate such kind of the voltage, it actually needs the three different coils to be connected, either connected in the star or either should be connected in the delta. So particularly this kind of the connection is called as a star connection. So here three coils are used. So for your illustration, I use the color notation for the different coils. So this one is the red coil, this one is the sky blue coil, and this one is the green. So for the three phases, you can see here all three phases are 120-degree apart. Means so first phase, as you can see, if you started with the 0, so this was the red phase. That means the sine wave. It is started with the 0 and it is keep going on this in this right hand side if the time is advances, and after 180-degree phase shift, other phase is started. That means it's 0 is started. So that this phase is often green. So it is given by this, and one more phase, that is total phase shift from the first one is the 120 plus 120, it is a 240, 240 from the red phase. So this is a total phase shift of the 240 degree. So there are three phases exist here. So that's why this kind of the circuit or this kind of the system is called as a three-phase system. And similarly, you might have observed in the case of the single phase, only the single sine wave you have observed, which is started from the 0. And there is no other sine waves, which is the phase shift version of the red one. So that is the three-phase system. So why three-phase? So three-phase we are using because first of all, the three-phase requires only the 75% of the copper or conductor. So that means it is economy. Means for the construction or for the particular project for generating the electricity, three-phase will be the more economical than the single phase. So that's why the three-phase system is used. Yes, second is the power continuity. Power continuity means if in the chances if one of the phases get failed means particular phase, that means vertical sine wave become a 0. So fail means it is possible that you can run a system by using a two-phase. So it gives the power continuity. And third one is the efficiency. So three-phase transformer is a more efficient than the single-phase transformer. That means the efficiency is more in this case. So that's why the efficiency point comes into the picture here. So, and third one is the losses. So losses in the case of the three-phase is minimum in case of the three-phase transformer. So three-phase connection types. So there are two types of the connection: star connection or star system, and second one is the delta connection or delta system. So let's say the star connection. So what is meant by the star connection is the in the star connection, there is a single common point. So this point is, you can call it as a neutral, and there are three phases here. One phase, this one is the second, and this one is the third. So it is connected to form a star. So that's why the name itself is a star. So as you can see, there are 4 wires total. So these are the wires, 3 wires connected to the each phases, and there is one more wire which is not shown here, so which is taken from the neutral. So there are 4 wires in the star connection, and this kind of the star connection is preferred for the long distance transmission. So if you are generating the electricity, and if you take the example of an MSCB, so MSCB, they are generating the electricity, they are generating unit, they are generating the electricity with this kind of the arrangement. They are using a star type of the connections. That means they connect the coils, three coils, to form a star connections. Okay. So that's why it is suitable for the long distance power transmission. So star connection, there are different phases you can see here. The voltage between line and line, it is called as a line to line voltage, or simply it is termed as a line voltage. And the current which is flows in this line, it is called as a line current. And current which is flows in the coil, or it is called as a phase. So current which is flow in the coil, it is called as a phase current, or phase current, or it is a current in the coil, it is also called as, but normally it is called as a phase current. And this phase current can be given by, yes, this line current and the phase current are same in case of the star connection, and line voltage is root 3 times of the VPH in case of the star connection. So this kind of the relations you can expect. That means, so this is a line to line voltage can be given by root 3 times of this phase voltage. So phase voltage means this is the voltage with respect to the neutral, phase voltage. So phase voltage at this point is, that means this is the voltage with respect to the neutral. So this is the relations that you can have in this kind of the star connection. Delta connection. So delta connection, as you can see here, only 3 wires are there. So 1, 2, 3. So 3 wires are there, and no neutral terminals in this delta connection. And this type of the delta connection is preferred for the short distance power transmission, because there is a kind of the unbalanced situation in the delta connection. So star connection is preferred than the delta connection. So because star connection, we can transmit the power over the longer distance, and in the delta connection you can transmit the power in the shorter distance. So delta connection, line to line voltage, these are the relation. That means line voltage is equal to phase voltage. That means line to line voltage is equal to the phase voltage. And the line current, the current which is flows in the line, it is given by the root 3 times of the phase current. So phase current is the current flowing in the coil. So it is root 3 times of that the phase current. So these are the relation in case of the delta connections. So let's solve the problem based on it. So 3 loads, each of the resistance 30 are connected in the star, and here the line voltage is given, that is 415 volt in the 3-phase supply. So you have to find out the system phase voltage, phase current, and line current. So here 415, that is voltage, is the line voltage is given for the 3-phase supply. That means 415 is the line voltage. So you know this relation between the star and delta. In case of the star, this relation is applicable. That means you can use this formula to calculate the to solve such kind of the problem. That means line voltage is root 3 times of the VPH, and line current is equal to IPH. So when you put this, that means line voltage is 415, you will get the phase voltage is around 240 volt, and the line current which is 239.6 divided by 13. That means the resistance in the phases. So you'll get the around the current around the 8 ampere. So let's solve some more problem based on it. In the case of the delta, so you can solve, there are 100 ohm resistance connected in the delta, and there is a line voltage of 415 voltage, and you have to determine the phase voltage, phase current, and the line current. So delta connection, these are the relation, and when you put the line voltage 415, you will get this, the line current, and you will get this line current and that phase current. So phase current is 4.15, and the line current is root 3 times of this. So can you connect the star connection source to the delta connection load? That means a star connection source can work with the delta connection load, or vice versa. So you can think about it. You can take a paper and you can write your answer and give it the justification. Answer is yes. So how? That means either you can connect the neutral unconnected, or you can connect the neutral to the ground. Yes, you can connect the star to the delta, delta to the star. So these are the references. Thank you.